An op-amp is a DC coupled high gain electronic voltage amplifier which uh, which dif which have differential input and a single output. So till now we discussed this up to this. So in case of op-amp, your symbol of op-amp is like this. See the symbol of op-amp. There are two terminals, as I say you. So one terminal is labeled as minus, and the other terminal is labeled as plus. This is the input terminal. Next is one output terminal. So here, this negative label terminal, it is called inverting terminal. Inverting terminal. And other one is called non-inverting terminal. Okay, this is the output terminal. Output terminal. So an op-amp is DC coupled, so it has two supply pins are there. So this is plus VCC and this one is minus V. This is the supply terminal. Either plus minus 12, plus 12 minus 12, or plus 15 minus 15. This type of supply voltage is given to the op-amp. Two input terminal, inverting terminal, non-inverting terminal. Across the output, you are getting difference of these two input signal is amplified by across the output. So suppose this across the V1 is plus terminal is V1 voltage, across the minus terminal is V2 voltage. Then and if gain of the op-amp is suppose A, then your output voltage V0 equal to gain into difference of the input voltage. So this is the output voltage. Okay. So whatever the input voltage is providing across the input side, across the output, you are getting the difference of the voltage. So this is all about the op-amp. Next is what are the application of op-amp? Application. Application of op-amp. So first is you can note down it is used for AC and DC signal amplification. Amplification. Okay. So whatever the signal, maybe AC, maybe DC, you can amplify by using the op-amp. Next one is other application is active filter can be designed by using the op-amp. So by using the op-amp, you can design the filter, active filter. Okay, active filter means there are two types of components are there, active component and passive component. So this resistance, capacitance, inductance, these are called the passive component, and this op-amp is active. It is the active, consider as the active element. So it is by using the op-amp, whatever the filter is designed is active filter. Now, what is filter? Filter is what? Suppose across the input side, there is a range of voltage or range of frequencies, but across the output side, you want to get some desired signal or some desired input frequency. So whatever the other frequency which you not want, that will be eliminated by using the filter circuit. Okay, that means what? Across the output, you are getting the desired signal, and rest other is eliminated by using the filter circuit. It is a filter. Clear up to this? Yes, no? Next application is your OPAMP is also used for designing the oscillator circuit. Last day, I was discussed oscillation, that positive feedback is used for designing the oscillator. I was discussed in the last class. So by using the OPAMP, you can design the oscillator circuit. Means across the output of oscillator, you are getting the oscillation types of these types of signal. Okay, or this type of signal oscillation. It is continuously minus infinity to plus infinity. This type of wave. It is the oscillation. Oscillation. So this type of circuit is also you can design by using the OPAMP. Oscillator circuit is designed by using the OPAMP. Next is the comparator circuit. OPAMP is also used for designing the comparator circuit. So what is comparator circuit? COM. So comparator circuit is what? Comparator circuit is that type of circuit which can compare the two voltages. So suppose across the input side there are two voltages, suppose V1 and V2, and you want to know which voltage is greater or which one is less. Okay, which one is greater and which one is less. So if you compare this V1 and V2, you can compare these two voltages by using the comparator circuit. And depending on this voltage, input voltage V1 and V2, corresponding your output waveform is generated across the output, which will decide which one is large, V1 or V2. So this type of comparator circuit is also designed by the help of what? By the help of OPAMP. Next application is OPAMP is also used for designing the voltage regulator circuit. Voltage regulator circuit or voltage regulator. Voltage regulator is what? Voltage regulator is such type of device whose output voltage is constant, even your input voltage is vary. Your input voltage vary, but the output voltage is constant. Output voltage constant. So voltage regulator is what? Voltage regulator is such type of device or circuit whose input voltage and voltages vary in a certain range, but the output voltage is constant. Okay, means if you supply a range of voltage across the input side, suppose V1 to V2, but across the output you are getting the constant voltage V0. It is constant. So this type of circuit is also designed, when a voltage regulated circuit is designed by the help of OPAMP. If any issue, you can stop me. Understand everyone? Next is analog to digital converter circuit. Analog to digital converter. So this analog to digital converter, this is also designed by the help of OPAMP. So what will be happen here? Here by using this analog to digital converter, an analog signal is converted into digital signal, equivalent digital signal. So this type of devices is also made by using the op. Is it okay? Next is just opposite, digital to analog converter circuit. Digital to analog converter. So digital to analog converter circuit is also designed by the help of OPAMP. So what is the application here? Here, by using this device, your digital signal is converted into analog signal. Here. So these are the a number of applications for the OPAMP. Up to this, okay, everyone? Can I change the page? Yes, no? बोलो. अभिरूप, आदित्य. Okay till now?
Yes, sir.
Now, the OPAMP internal OPAMP is basically designed by the help of transistor. So in the OPAMP IC 741, it is made by the Intel. So two input terminals are there. One is the minus terminal and other is the plus terminal. Inverting terminal and non-inverting terminal. This is the input impedance Ri. Ri is the input impedance and this is the output side impedance R0. This is your V0 and here this is inside AV0. So here Ri is the this V1 and V2 is the input voltage of minus terminal and plus terminal. This Ri is the input impedance of OPAMP. R0 is the output impedance of OPAMP and V0 is the output voltage. So here your V0 equal to this is AVD, where VD is the difference of these two voltages. So your output voltage V0 equal to A into VD. VD means difference of V1 and V2. So it is A into V1 difference V2. So you can see here, if the plus terminal voltage is high, then across the output you are getting plus voltage. And if the minus terminal is high, then across the output you are getting the minus voltage. Up to this, okay? Next is characteristic of OPAMP. Characteristic of of OPAMP. So here we discuss the characteristic of ideal OPAMP, and parallelly we also discuss about the practical things. So ideal OPAMP. So first characteristic is what? First is input impedance of the OPAMP is input impedance of OPAMP is infinite. So for ideal OPAMP, the input impedance is infinite, and for practical OPAMP, this impedance is very high value. For practical things, it is very high value. Second one is output impedance. Means across the output side, ideally there is no resistance drop, and practically very low resistance drop. So output impedance of OPAMP is, for ideal case, it is 0, and for practical case, it is very low. Okay. Next is gain of the OPAMP. So next, gain of the OPAMP. So for ideal amplifier or for ideal OPAMP, gain is infinite. Ideally, the gain of the OPAMP is infinite, but in the practical case, देखो, we are our target is ideal, but we are not getting the infinite thing. We are getting the gain or input impedance or output. These all are in a physical value, or in a, maybe it is high, maybe it is low, but not the infinite value. Okay. So in the ideally the gain of the OPAMP is infinite, but practically it is very high value. Next characteristic is your bandwidth of ideal OPAMP is infinite. Bandwidth means across the output side you are getting infinite, but all types of frequency, all types of voltage. Okay, but ideally it is not. Ideally it is infinite, but practically your bandwidth is high value. Means you are getting a very high range of frequency across the output, but it should be high, but it should be not infinite for the practical. Okay, so ideally it is infinite bandwidth. Next point is perfect balance. Perfect balance. You can note down perfect balance. That is when same voltage is applied to both terminal, then output is 0. Then output is 0. What do you understand by this? देखो, up to this, okay? Everyone write down it. Then I will explain. देखो, perfect balance is what? In case of OPAMP, your in case of OPAMP, your when you supply this is a minus terminal, this is the plus terminal. Suppose this is V1, this is V2. Across the output, you are getting V0, and V0 equal to A into V1 minus V2 or V1 difference bit. Now, when this V1 and V2 is same, both are equal, in that case, this V1 minus V2 is equal to 0. If both voltages are same, then A into 0 is equal to 0. Okay, so means when you apply the same voltage across the output side, same voltage, then your output will be 0. If you are applying the same voltage across the input side and output is 0, that means your op-amp is perfectly balanced. Okay, it is the ideal. When you apply the same voltage across the input side and you are getting the 0 voltage across the output side, so this is the ideal case, and here the op-amp is perfectly balanced. That means the minus terminal, the weightage of minus terminal and the weightage of plus terminal is equal, and across the output you are getting 0. This is the mean. But in practical case, if you supply the same voltage across the op-amp, across the amplifier, then you are not getting the 0. You are getting a very low voltage, and this low voltage is either positive or negative. If the low voltage is positive, that means this plus terminal weightage is high. And if the minus terminal weightage is low. And if the minus terminal voltage and if the output voltage is negative, output voltage is negative for the same voltage, means your negative terminal weightage is high and positive terminal weightage is low. Okay, so if this kind of things are happen, then we try to balance the op-amp, we try to minimize the op-amp, and we try to achieve this 0 value or close to 0 value. We try to achieve the voltage very close to 0 for the same input voltage. Okay, but we are not getting the 0, we are getting the very close to 0. So this is the perfect balance. Clear? Next point is, up to this, okay? Can I change the page? Yes, no? It is a hello. Perfect. Wait a second. Acha. Okay, next is infinite CMRN and infinite slew rate. Next point is 6 number point. Point number 6 is point number 6 is point number 6. Next is point number 6 is infinite CMRR. Infinite CMRR. CMRR full form is common mode rejection ratio. Infinite CMRR common mode rejection ratio. And this CMRR is CMRR equal to AD by ACM. Where AD is what? Where AD is the differential voltage gain. Differential voltage gain. And ACM is called common mode voltage gain. AD and ACM. Now, what is AD and what is ACM? AD is what? When you supply the different voltage across the input side, different voltage. In that case, the gain of the op-amp is what? A. So this A is called the differential voltage gain. When you supply the different voltage, means not same voltage, V1 when V2 is not equal voltage. In that case, whatever the gain of the op-amp, that is called AD. So this AD is differential voltage gain. What is it? When you supply the different voltage across the input side, means your V1 and V2 is not equal, not same. In that case, the gain of the op-amp is 80. And ACM is what? ACM is when you supply the same voltage, your V1 and V2 is equal. In that case, you are getting across the output side, ideally you are getting the 0, but practically you are getting very small voltage. Okay. So if you are getting very small voltage across the output side, then your gain will be very small. So this is called ACM. ACM is what? ACM is the voltage gain, common mode voltage gain. It is the voltage gain when you are supplying the same voltage across the input terminal. I think it is clear to all of you. Next point is point number 7 is infinite slew rate. Infinite slew rate. So this CMRR is infinite for the ideal op-amp and practically it is very high value. Same your slew rate is also infinite for the ideal case, ideal op-amp, and practically this slew rate is very high value. Now what is slew rate? Because slew rate defines that any types of amplifier or any types of devices, suppose this is any types of device or suppose there is a op-amp, So you supply the input signal and you are getting the output signal. Okay. So first input signal is supplying, then the input signal is processing, then you are getting the output signal. Means if you supply the input signal, suppose at the time t1, then this t1 is processed for a certain duration of time, and after that you are getting the signal v0 at the time t2. Okay, so this slew rate defines that how quick you are getting the output when you supply the input. This slew rate defines that how fast you are getting the output signal when you provide the input signal. So ideally you are supplying the input, you are getting the output at same time, ideally. But practically you supplying the input and after some delay you getting the output. So this is the practical case. So when the slew rate is infinite, you are getting the output and input at the same time. But practically it is not possible. Practically there are some delay. So infinite slew rate for the ideal op-amp, and practically the slew rate value is very high. I think it is clear to everyone. ठीक है? ज्यादा हो जाए या फिर इच्छा नहीं हो, जो हो दिक्कत रिस्पॉन्स करो, बताओ। नहीं समझ में आया वो भी बताओ, समझ में आया वो भी बताओ। It is okay till now?
Yes.
Okay. Then next topic is virtual ground. Virtual ground. वर्चुअल ग्राउंड क्या होता है देखो, वर्चुअल in case of op-amp, this is the symbol of op-amp, minus terminal, plus terminal. This is suppose resistance R. Here the input voltage is suppose V in. V in is the input voltage. This is the ground symbol. Plus minus your input voltage. This positive terminal is grounded. These both are ground. Okay, different symbol for ground. Supply voltage is plus VCC minus VEE plus 12 minus 12 or plus 15 minus 15 like this. Then there is the feedback path. Through this path, through this resistance, your input side is connected with the output side. This is the input side. This is the input side, and this one is the output side. So by using this resistance, your input and output is connected. So this resistance is called RF or feedback resistance, through which your input is connected with the output. Now see here. Here this is negative terminal. Suppose here the current going to the inside this terminal is IB1, and this terminal current is suppose IB2. This terminal is grounded, you can see here. So now you can see the ideal for the ideal op-amp, the input impedance is what? For the ideal op-amp, the input impedance Ri equal to infinite. We know this. Means here inside there is the Ri resistance, and which is ideally infinite. So if this input resistance is infinite, this input current going to the inside IB1 and IB2, it is equal to what? If the resistance is infinite, then current is what? IB1 equal to IB2 equal to 0. If the resistance is infinite, the current flowing is 0. So here the IB1 and IB2, it is 0. Here IB1 and IB2 is 0. Now for an for an op-amp, suppose this terminal, this voltage and this, suppose this is X terminal and this is Y terminal. Voltage at this terminal is suppose Vx and voltage at this terminal is suppose Vy. And the difference between these two terminal voltage is Vd. Okay. So your Vd is what? Vd is difference of Vx minus Vy. Vd is the differential voltage. माने इस दोनों टर्मिनल के बीच में जो वोल्टेज का डिफरेंस है दैट विल बी Vt. Okay. Now here ideally this Vx and Vy is 0. For the op-amp it is 0. In case of feedback amplifier where there is a feedback path, this Vd is equal to 0. That means your Vx is equal to what? Vx is equal to Vy. So you can see here this Vy terminal is grounded. So here the Vy equal to 0. Your Vy equal to 0. So therefore your Vx is also equal to 0. So here you can see your Vy is although this X terminal is not directly connected to ground, but the voltage at this terminal is 0. So it is called virtually ground. Your node X is virtually ground. Okay, you can note down here the node X. Here the node X is not directly connected to ground, but the voltage at this point is 0. Vx equal to 0. So it is called virtual ground. Okay. So here your Vx is virtually ground. Up to this, okay? Yes, no. कोई इश्यू हो पूछ लो. Can I change the page?
Yes, sir.
Okay.
Yes, sir.
Okay. Yes. Next is different mode of op-amp. Different mode of op-amp. So there are basically three modes are there. First one is inverting amplifier. Inverting amplifier or inverting mode of amplifier. Inverting mode of op-amp. Op-amp working inverting mode. So what is it? So in case of inverting mode, your signal voltage is applied to the inverting terminal. One is minus terminal, other is plus terminal. Here there is a supply voltage plus VCC, and there is a minus VE minus plus. So here your input signal is applied to the, in case of inverting amplifier, minus terminal is the inverting terminal. So in case of inverting amplifier, your input voltage is applied to the inverting terminal. So here your input voltage is applied to the inverting terminal. Suppose V in is the inverting terminal, R is the input resistance. Here this terminal is grounded and output is V0. Output is V0 and there is the feedback path RF. Same circuit as the previous one. RF is the feedback resistance RF. So here inverting, in case of inverting amplifier, your signal voltage माने the voltage which is amplified, जिसको amplify करना है, that voltage is applied to the inverting terminal. Negative terminal is the inverting terminal, positive terminal is the non-inverting terminal. So your signal voltage is applied to the inverting terminal. Here in this case, your output voltage V0 equal to, it is minus RF by R into V. This is the output voltage. So here V0 equal to minus RF by R or Rin. So V0 by Vin is what? V0 by Vin is the gain of the op-amp and it is equal to minus RF by R. So here minus RF by R is the gain of the op-amp, or you can say it is AF, gain of the op-amp in inverting amplifier, inverting mode. This is the gain. Gain. Okay. Can I change the page? Yes, no. Next is number 2, non-inverting mode of operation or non-inverting amplifier. Non-inverting mode of operation or non-inverting amplifier. Non-inverting amplifier. So this is just opposite to the previous case. In the previous case, your signal is applied to the inverting terminal. Here the signal is applied to the non-inverting terminal. So here your circuit is like this. This is the op-amp. Minus terminal means inverting terminal, plus terminal means non-inverting terminal. There is the input resistance R in or R whatever. This is input resistance. You can write by R or R in. Your signal voltage is applied to the positive terminal. So this is your signal voltage. Okay. Now same, there is the feedback path. If you are not providing the feedback path, your output is going to the saturation state. We discussed the saturation state in last class. So here same, your output is plus maximum or minus maximum if you are not apply the negative feedback. So why it is negative feedback? Because your output is going to the negative feedback to the negative terminal. It is negative feedback. RF is the feedback resistance here, the resistance which is connected in the feedback part, RF. Now here your output voltage V0 equal to 1 plus RF by R into V into V in. So this is the so output voltage V is equal to 1 plus RF by R. You can see your gain is depend on the input resistance and feedback resistance. Same here, output, here gain of the op-amp is AF equal to what? Output by input, V0 by V in. Gain is output voltage by input voltage, and it is equal to 1 plus RF by RE. This is the gain of the op-amp. Inverting amplifier, non-inverting amplifier. These two mode. And third one is the differential amplifier. Differential amplifier. So in case of differential amplifier, your signal, third one is differential amplifier. Differential amplifier. So in case of differential amplifier, your signal voltage is applied to the both terminal, inverting terminal and non-inverting terminal. Differential amplifier. So here, this is input resistance R, and your voltage is suppose V2. There is the input resistance, same as this one, it is R. This is also R, ground here. This is V1. There is the feedback resistance. This is V0. This is RF. So in case of differential amplifier, signal voltage is applied to both terminal, and here your output equal to V0 equal to RF by R. RF by R into V1 minus V2. So this is the voltage for the differential amplifier. Okay, up to this okay. Next, this op-amp is by using the op-amp. You can see here the term is operational. The name is operational. Why it is called operational? Because by using this op-amp, you can design the circuit which can perform the mathematical and logical operation. By using the op-amp, you can design the circuit which can perform the mathematical and logical operation. That means you can design the mathematical circuit like adder, like subtractor, like logarithmic circuit, like anti-logarithmic circuit, this type of mathematical operation you can perform by the circuit which is designing by the help of op-amp. Same some logical circuit like comparator circuit we also discuss in the application part, that two voltage V1 and V2 is compare. So this types of logical circuit is also designed by the help of comparator. So these are also the application part. For today's class, up to this, any question you have, you can ask. Otherwise, I will stop at this point. Any query? Can I stop the sharing? Yes, no? Can I stop the sharing?
Yes.
Yes, sir.
Yes, sir.
Okay, sharing is stopped. And just wait a second. I will share. Uh, wait a second. Where it is? Wait a second. ABS, 790. For attendance, just wait for 1 minute.